So this here will be the end of chapter 7.52 and chapter 7 notes. So today is the last day we'll be covering notes over chapter 7. So we'll be looking at this problem and the next two. So we'll be looking at 3 of the last 4 problems in the note sheet today. This here is the problem we finished off with. We didn't start this one yet, because I believe this is where we ended. Now, the numerators in any of these here, for right now, are going to stay the same. Now, the denominators, we do need to factor them if any of them are factorable. And looking at these 3 here, there are 2 denominators that are factorable. The x squared minus 9 and the x squared minus 6x plus 9. Well, our x squared minus 9 is going to factor to what? Well, x plus 3 and x minus 3, because it's a difference of perfect squares. Now the middle one, x squared minus 6x plus 9, will factor. Because the 9 is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. The factors of x squared are x and x. And well, the factors of 9 that we would want would be 3 and 3. And in the last one, we would have x plus 3. Now, before we move on and figuring out what we need to multiply each of these rational expressions by to get the denominators to simplify out, it would be good to know what the restrictions are. So when we look at these 3 denominators, what's going to make each one of these sets of parentheses become 0? 3 and negative 3. Because, if I get a highlighter out, the 3 is going to make the x minus 3's here be 0, because 3 minus 3 would be 0. The negative 3 is going to make this x plus 3 and this x plus 3 both be 0, and that's all the denominators. So we know that x cannot be 3 or negative 3. Okay. Now that we do have the restrictions, we can go on and start solving by multiplying each one of these expressions by a certain set of terms so that the denominators would simplify out. So what would we need to multiply everything by? So an x plus 3, x minus 3, and x minus 3. So we're going to need x plus 3, x minus 3, and x minus 3. Over here we'll have x plus 3, x minus 3, and x minus 3. And here we do need x minus 3 twice because the middle term has x minus 3 in the denominator twice. So we need it twice. And now we can see what simplifies. In the first one, the x plus 3 and x plus 3 would cancel. And one of the x minus 3's would cancel with one of the x minus 3's. So we'd only have one. In the middle, we'd have the x minus 3 cancel with the x minus 3. And x minus 3 cancel with the x minus 3. And lastly, we'll have an x plus 3 cancel with an x plus 3. And what we have left over is in the first one we have 4x times x minus 3 is equal to x minus 1 times x plus 3 plus 2 times, well, what do we have? Yeah, x minus 3 times x minus 3, yes? Well, where did we get that from? The x squared minus 6x minus, or plus 9? Well, we can go on and put that back in. As if it does work out, 2 of the things we do have left over is something we factored it from. We can go on and put it in. Now at the middle one, the x plus 1 times x plus 3, we didn't have that factored from anywhere, so we kind of have to put it back down. We don't get a nice little shortcut like we did for the x minus 3 times x minus 3. Now at this point here, we need to solve, so we do need to use our distributive properties. So here we can multiply through with the 4x. So 4x times x would give us 4x squared. 4x times negative 3 would be our negative 12x is equal to, first we're going to distribute the x. X times x is going to give us x squared. X times 3 is going to be plus 3x. Do the same thing with negative 1. Negative 1 times x is going to be negative x, and negative 1 times 3 is negative 3. And the last thing we need to distribute is the 2. 2 times x squared is going to be plus 2x squared. 2 times negative 6x is going to be negative 12x. And lastly, 2 times 9 is going to be plus 18. Now at this point here, we will need to combine our like terms. So x squared and 2x squared is going to give us 3x squared. Three x minus x is 2x. Minus 12x is negative 10x. And lastly, negative 3 plus 18 is plus 15. Now we do have x squared term, so it means that we're going to need to get this thing equal to 0. So what would we want to do first to get this equal to 0? We can add 12x to both sides, yes. And if we add 12x to both sides, well, negative 12x plus 12x is 0, leaving us with 4x squared is equal to 3x squared. And negative 10x plus 12x is going to be plus 2x plus 15. What would we need to do next? We're going to subtract 4x squared. If we subtract 4x squared from both sides, we're going to get that 0 is equal to negative x squared plus 2x plus 15. Because these here would cancel out. Any questions on how we got to this quadratic? Now, I have a feeling that y'all are going to want to factor. We're going to solve it by factoring. Now, the first thing to factor out would be a greatest common factor, if there is one. Yes. Now, there's not a specific term, and I still haven't figured out why this thing is scrolling. I'll do it again. See if that helped. All right. Okay. So we'd have 0 equals negative, and we would have x squared plus 2x plus 15. Because what we're wanting to do is to pull that, well, almost. Okay, now it's not going to scroll. Good. We want to pull that negative out. This isn't something you have to do. I like keeping the x squared positive. Since we have a negative x squared, I'm going to factor that negative out. Because if I factor the negative out, it takes the x squared from being negative to positive, something we're used to working with. It's going to take the positive 2x and make it negative, and it's going to take the 15 and make it negative. Now, it is possible to factor it with negative x squared, but if we do that, we have to take into account that the numbers with our x squared, the factors with our x squared, would be negative and positive. We have to take that into account. But if we factor that negative out, we can continue to do it and factor like we're used to doing. So I like keeping that x squared positive because it makes it a little bit easier to work with. Now, since the 15 is negative, our signs are going to be opposite. One's going to be positive and one is going to be negative. Well, the factors of x squared are x and x. And the factors of 15 that we want, 5. And the 5 is with the minus, yes. Any questions on how we got to this point here? Now we do have two things multiplied together to equal 0, so it means one of them must be 0. So either x plus 3 is equal to 0 or x minus 5 is equal to 0. Now for the x plus 3, we can subtract 3 from both sides, telling us x is negative 3. Over here we can add 5 to both sides, telling us x is equal to 5. Any questions on how we got negative 3 or 5? But what did we say the restrictions were? 3 and negative 3. Did one of them show up? So x equals negative 3 is not one of the solutions that works back in the original problem. It's one of our extraneous solutions. So really the only solution for this here is x is equal to 5. And that's it. Any questions on this here? Are you ready for the next one? Question, Leah? Okay. Let's look at this one here. So this one here, looking at it right now, can y'all tell me what the restrictions would be? Right, we can say 2 and negative 2 for sure, yes? Is the x plus 2 and x minus 2. Do we know what it would be for the x squared minus 4? It would actually still be 2 and negative 2. So it might be a little bit easier to look at it if we factored it. Because the x plus 2 and x minus 2 in our first two rational expressions won't simplify or factor any further than they already are. They're already simplest form. Now the x squared minus 4 is a difference of perfect squares, which actually factors 2. X minus 2 times x plus 2, or we could actually say it x plus 2 times x minus 2. Either way still works. And after we factor it, okay, we can see 2 and negative 2 still work for this one here. Okay. So what do we need to multiply each one of these by? Well, x plus 2 and x minus 2. And if we do this multiplication here for the first one, the x minus 2 and x minus 2 would cancel. In the middle rational expression, the x plus 2 and x plus 2 would cancel. And in the last one, x minus 2 and x minus 2 would cancel, and the x plus 2 and x plus 2 would cancel, leaving us with, on the first one, we would have 9 times x plus 2 plus x times x minus 2 is equal to, well, 9x squared. Now, unfortunately, with this one here, we can't use any of the shortcuts to get to the answer, or factor or simplify any of these down. But luckily, when we distribute the 9 and the 6x, it's actually not that bad. Because 9 times x would be 9x. Plus 9 times 2 would be 18. If we do the same thing with 6x, well, 6x times x is going to be 6x squared. And 6x times negative 2 would be negative 12x is equal to 9x squared. Now, we can simplify some like terms. There are a few spots where we do have like terms. On the left-hand side, well, the 6x squared doesn't have any like terms. But the 9x and negative 12x are like terms, which gives us a negative 3x plus 18 is equal to 9x squared. Well, because we do have an x squared, we do need to get this equal to what? 0. So we're going to 9x squared from both sides. I'm going to roll up a little bit so we can see it. So we get this here. Well, the 9x squared and 9x squared would cancel out. 6x squared minus 9x squared would be negative 3x squared. And we have minus 3x plus 18 is equal to 0. Now, we can try to factor this. And before we do any factoring, we need to see, is there a greatest common factor? Negative 3. And it does make it a little bit easier to work with if we factor the negative out with the 3. Because if I factor a negative 3 out of negative 3x squared, we're just left with the x squared. If we factor 3 out of negative 3x, negative 3 out of negative 3x, negative would change it to plus, and we have x minus 6. So the negative really just changed the sign, so the x squared became positive, the x became positive, and the 18 became negative. Factoring out the 3 left us with x squared, x, and 6. Any questions on this here before we finish this up by factoring? Now, because the 6 is negative, our signs are going to be opposite. One's going to be positive, one's going to be negative. Now, the factors of x squared are x and x. And what factors of 6 do we want? 3 and 2, and the 3 would be positive. Now, what this is telling me is that either x plus 3 is equal to 0 or x minus 2 is equal to 0. Because the only way that we can have 2 or more things multiplied together and equal 0 is if one of them is 0. So the first one here, we can subtract 3 from both sides. So minus x is equal to negative 3. On the other one, we would add 2 to both sides, telling us x is equal to 2. So solving this here, we found out that x is negative 3 and 2, but our restrictions tell us that x cannot be what? 2 or negative 2. Do we have one of these as a solution? Yes. So the solution of x is equal to 2 does not work because it is one of our restrictions. So the only real solution for this here is x is equal to negative 3. And that's it for this here. Any questions on any of these here? Okay. Let's look at this one here. Now we look at this one. The only real difference is that this time we have 5. We have a term without a denominator. And that's not really going to change anything or how we solve this here. It's just going to make it look a little bit different. But before we can start solving or going through our process of solving, we do need to factor one of the denominators, the x squared minus 1, which would factor to x minus 1 and x plus 1, because it is a difference of perfect squares. And now that we have all the denominators factored, we can go on and find the restrictions, which in this case would be negative 1 and, because for x minus 1 and x minus 1, if x is 1, it would make those 0. And for our x plus 1, well, if it is negative 1, it would make it 0. So for our solutions for this here, we can't have x being negative 1 or 1. Now, what do we need to multiply each one of these by? Yes, x plus 1 and x minus 1. And in our first rational expression, the x minus 1 and x minus 1 would cancel. What would simplify out with the 5? Nothing. There is no denominator, so there's nothing to simplify with. And then with the last one, well, the x minus 1 and x minus 1 would cancel. And the x plus 1 and x plus 1 would cancel out. Any questions on this here? Now, when we look at what's left, well, to start off with, we have 7 times x plus 1 minus 5 times, yes and yes, is we would have the x plus 1 times x minus 1. But where did we get that from? We got it from the x squared minus 1, yes? So, I mean, it's not wrong to put x plus 1 times x minus 1. Because if we do multiply those back together, we would get back to x squared minus 1. So if we do see that that does turn back into x squared minus 1, we can go on and just write x squared minus 1. But if we had written out x plus 1 times x minus 1, when we go through the next step of actually multiplying them together, we would actually get back to x squared minus 1. Now we need to distribute. And then I had a feeling it was going to do that. Well, our 7 times x is going to be 7x. 7 times 1 is going to be plus 7. Multiply through with the negative 5. Well, negative 5 times x squared is negative 5x squared. And negative 5 times negative 1 is going to be plus 5 is equal to 6. Now at this point here, we do need to combine our like terms. Well, the negative 5x squared does not have any like terms, or does the 7x. But our 7 and 5 are like terms, which gives us plus 12. Now, because we do have quadratic terms, the x squared, we do need to get this equal to what? 0. So the last thing we need to do before we can start factoring is to subtract 6 from both sides, which will tell us that negative 5x squared plus 7x plus 6 is equal to 0. What can we do next? Factor out what? Yes, and what would the greatest common factor be? Is there a number that goes into 5, 7, and 6? Well, no, but there is something that I would pull out. I would pull the negative out. Because if we pull that negative out, it's going to turn the negative 5x squared into being positive. It's going to turn the 7x from positive to negative, and it's going to turn the 6 from being negative, positive to being negative. Negative. Now, because the 6 is negative inside the parentheses, it means our signs are opposite. One's positive and one is negative. Now we need to look at the factors of 5x squared and 6. Well, we know x squared is going to factor 2 x and x. That's the only setup that we can have for x squared. Now the factors of 5 are, well, 5 and 1. Where do we want to put the 5? Put it with the plus or with the minus? I'm just going to throw it in the first one. That's just my personal preference. I like throwing it in the first spot. It might be that we have to change the signs, but we'll put it there. How about the factors of 6? 1 and 6 or 2 and 3? 2 and 3, where do we want to put the 2? Okay. We can put the 3 over here. Now we can go on and check it to make sure we did this right, because again, we have a few more variables and the signs are opposite, so it might be good to check this one. 5x times negative 2 is negative 10x. 3 times x is going to be a plus 3x. And negative 10x plus 3x is a negative 7x. Is that what we wanted? Well, yes. So these are the correct factors. And whenever we have two things multiplied together to equal 0, it's telling me that one of these must be 0. Well, for the 5x plus 3 equal to 0, well, the first thing we can do is subtract 3 from both sides, which would tell us that 5x is equal to negative 3. And then we would divide both sides by 5, telling us x is equal to negative 3/5. And for the other one, we would add 2 to both sides, telling us x is equal to 2. Negative 1 and 1. Well, are either one of these our restrictions? No, so the solutions for this one here actually work out to be 2 and negative 3/5. Any questions on this here? All right. I do know I said at the beginning we were doing 3, and we did do 3. I still want to look at this one because it is a little bit different, and it does show you something that I think is kind of nice to see, or good to see. Probably not nice, but it is good to see. One, two, 1. Now looking at this here, well, the x minus 1 and x plus 1 won't simplify any further than what they are, because they are already in a factored form. But we will need to factor the x squared minus x minus 2. Since the 2 is negative, our signs are going to be opposite. One's going to be positive, one's going to be negative. Now the factors of x squared exactly are x and x. Now the factors of 2 are, well, 1 and 2. Do we want the 2 to be positive or negative? Almost. We'll want it to be negative, because the middle term is a negative x. Now, because the number in front of x is 1, so we're really looking to see what factors of 2 add together or combine together to give us a negative 1. So we would want to have negative 2 plus 1 to get the negative 1. And if we did check this here, because x times negative 2 would be negative 2x. 1 times x is plus x, which would give us a negative x, like we wanted. Now, if we look at the restrictions, well, we could say x cannot be, well, negative 1, 2, or 1. Negative 1, 2, or 1, because any of those values would make one of the denominators be 0. So up to this point, really, has anything changed for this here? Well, no. What do we need to multiply everything by? X. X minus 1, x plus 1, and x minus 2. X minus 1, x plus 1, x minus 2, x minus 1, x plus 1, x minus 2. And in the first one, the x minus 1 and x minus 1 would cancel. In the middle one, the x plus 1 and x plus 1 would cancel. And in the last one, our x plus 1 and x plus 1 would cancel. And the x minus 2 and x minus 2 would cancel, leaving us with 2 times. We have x minus 2 times x plus 1, yes? Where did we get those from? Well, there's nothing wrong with writing it out. We got it from the x squared minus x minus 2, yes? What would happen if I multiplied x plus 1 times x minus 2? Well, we would get back to this here, yes? So if you didn't notice that, or didn't see that that's where we got that from, that's perfectly fine. Because if we did multiply, we would get back there anyways. So writing it down here instead of x squared minus x minus 2 as x plus 1 times x minus 2 will still get you to the same place. We're just skipping a step. Now in the middle one, we're going to have 1 times, well, if I can write it without it scrolling, times x minus 1 times x minus 2, which is just x minus 1 times x minus 2. Now, unfortunately, with this one here, we can't use that same shortcut because, well, we didn't factor in x minus 1 times x minus 2 from anything, did we? No, so we'll have to write it back out. And lastly, we have x minus 1. Now, at this point here, we do need to distribute, and then we'll combine like terms. So for the first one, we're going to distribute the 2. Well, 2 times x squared is going to be 2x squared. 2 times our negative x is going to be negative 2x. And 2 times negative 2 is going to give us a negative 4. Plus. In the middle, we'll have to use our distributive property all the way out. So x times x would give us x squared. X times negative 2 would be negative 2x. Negative 1 times x would be negative x. And negative 1 times negative 2 is going to be plus 2 is equal to x minus 1. Now we can combine our like terms on the left-hand side. And the 2x squared plus x squared would give us 3x squared. Our negative 2x minus 2x minus x is negative 5x. And lastly, we have our negative 4 plus 2 is equal to x minus 1. Well, luckily, if we look at this here, we have all the x squareds on the same side, yes? And they're all positive, so we don't have to worry about factoring out negatives or dealing with a negative x squared. But we do need this equal to 0. So the first thing we can do is what? Add 1 or subtract x. Or if we wanted to, we could actually do it all in one step. Because if I wanted to, I mean, I could write it like this here and do them both at once because they are independent steps. It doesn't have to be done in two different steps. I could do it all at once. And if we did it, well, we would get 3x squared minus 6x minus 1 is equal to 0. And we would get the exact same thing if we did those two steps independently. Well, I'm going to tell you this doesn't factor. Because if we're factoring, we're really looking at factors of 3 and 1 that multiply and then add and subtract to get to 6. Well, there's no way that the factors of 3, really, 3 by themselves are going to get us to 6. Because the only factors of 3 are 3 and 1, and there's no way that they add together to be 6. It just doesn't work. So we're going to use the quadratic formula for this here. So here, we would have our ax squared plus bx plus c. Can I write this down just as so we have a reference to what a, b, and c are in the quadratic formula? And as we plug this in, well, negative b would be our negative 6 plus or minus negative 6 squared minus 4. Well, a in our case is 3, and c is negative 1. And we will take the sign with it over 2a, which would be 2 times 3. And when we did this last, we went on and did some simplifications all at once. But here I just wanted to write it down all the way out because it's been a little while since we've seen it. Now the first part, the negative 6, well, a negative and negative would make a positive. So we have positive 6. On bottom, 2 times 3 is actually just 6. Now for the radical, well, we said this doesn't factor, yes? So am I expecting that the square root of negative 6 squared minus 4 times 3 times negative 1 to come out to be a whole number? Well, no, because if it did, then this would actually have factored. So I would plug everything inside the radical into the calculator first without the radical. Well, negative 6 squared is actually 36 minus, well, 4 times 3 is 12 times negative 1 is negative 12. It actually would give us 36 plus 12, which is, so what goes inside the radical is going to be 48. Now, as we already said, we have a feeling that, well, the square root of 48 is not going to simplify down to a whole number. And if we know the perfect squares, well, 36, and then it would be 49, so it's not a perfect square. But 48 is 16 times 3. And I can take the square root of 16, which is 4. And we're left with square root of 3. So this here in the quadratic formula will get us down to 6 plus or minus 4 square root of 3 over 6. Any questions on this here? Do these three numbers have something in common? 2, because 4, 6, and 6 all do have a greatest common factor of 2 that can be simplified out. And if I pull a 2 out of all of them, well, if I divide 6 by 2, I get 3 plus or minus 2 square root of 3 over 3. And that's one way to jump to it. Now we can do that kind of method as long as all three numbers have the same divisors, have the same number in common. But really what we did to kind of jump to there is, well, I factored a 2 out of the numerator, which leaves us with 3 plus or minus 2 square root of 3 over 6. Well, 2 over 6 reduces to 1 over 3. We don't have to write the 1 in the numerator, which gives us this here. Well, our restrictions were what? 1, -1, and 2, yes? Is 3 plus or minus 2 squared root of 3 over 3 one of our restrictions? Well, no, it's an irrational number. It's a non-repeating, non-terminating decimal. So is that still the solution? Well, yes. And the reason I showed this one here is kind of to show you all that, I mean, the solutions don't have to be nice whole numbers. We can actually have these irrational numbers as part of the solution. And most often, when we're doing stuff like this, when rational equations come into a real-world setup or a real-world problem that you're looking at, we're more likely to get ugly-looking numbers than nice whole numbers. But that's it. Any other questions on this here? And that is all we are doing for Chapter 7. Chapter 7. So your homework for this here is on page 400, 23 through 26, 29, and 30.